This is video number 1 of Chapter 1, Lesson 5, and in this lesson we're going to look at 3 topics. We're going to look at absolute value equations, absolute value inequalities, and then we're going to revisit tolerance. Now, to review some things about absolute value, we talked about earlier in the year that the absolute value, remember, is the distance from 0 on a number line. And remember, we can either go to the right, which is positive, or we can go to the left, which is negative, but the distance that we go is what the absolute value represents, how far we go. Okay? It can never be negative because the distance that you travel, whether you go to the right 3 or to the left 3, you still went the same distance. You went 3. The only difference is the direction. So in this case, the negative sign really just tells me the direction that I'm going to end up going. Now, because you can either go to the right 3 or to the left 3, when we're looking at absolute value equations, we're always going to get 2 answers. We're going to have 2 solutions. And remember, for solutions, we're looking for numbers that we could substitute into the expression that would make it true. And because we're doing absolute value and I can go to the right and to the left the exact same distance, I can get a positive number that will satisfy the solution or the expression, and I also can get a negative number that will also satisfy the solution because we're talking about distance, how far you go, whether it be to the left or to the right. Now, when we do this algebraically, we may produce what we call extraneous solutions, and I'll talk about this more in depth later. But basically what it means is we can do all the math correct, we can find our 2 solutions, but when we go and substitute those solutions back into the original expression, we're not going to get something that's true. So even though we've done everything right, the answers don't satisfy the equation or the expression, therefore they are extraneous even though they are solutions. A couple other things about absolute value before we look at a couple examples. In order to solve these equations, we're going to isolate the absolute value. Remember, when we talk about solving equations, when we're solving for x, we need to get x by itself or isolate x. And once we get the x by itself, then the last thing we do is we divide by that coefficient, whatever it is. Well, here we're solving absolute value equations. So think about the absolute value as the thing that you're solving for. So the absolute value, that expression, has to be by itself before you can actually solve the expression. And so we'll look at that, and but think about that in the same terms, and I'll do an example here in a moment. Again, we're always going to get 2 solutions, and this is, again, an explanation of how you do it. Then I'll show you a couple examples. So what you do is, once the absolute value expression is by itself, you take what's inside the absolute value and you set it equal to the positive of whatever's on the other side, and then you set it to the negative of whatever is on the other side. Okay? And that's how you're going to solve these expressions. All right? So let's take a look at a couple of other things I want to talk about. First of all, since absolute value represents distance from 0, so whenever I see absolute value, they're saying put a number in here that is this far away from 0. Well, if this is a distance from 0, this can never be negative. So anytime you see a negative number over here, you can just, whoops, I'm trying to talk and write at the same time, I'm not getting that. Never negative. In other words, if I see absolute value is equal to -3, well, here's a problem. The distance from 0 is -3, but what did we say? Distance can never be 0. So as soon as I see this as a negative number over here, I don't do anything else. I just say right away there's no solution. Okay, this one has no solution because distance can't be negative. So that's one of the cases I want you to be aware of, and make sure that you don't make the mistake of starting to set up equations when we can't, because distance can't be negative. Let's see. You're always going to produce 2 equations when you have this absolute value. Okay? So, for instance, if I have the absolute value of x is equal to 7, because it's absolute value, it's distance from 0. If I think about this, I'm going to think about it over here. This is the distance that I need to go from 0. I need to go 7. Well, I can go 7 in the positive direction. So the number that I put in here, x, can be equal to 7 going in the positive direction. So that can be one of my equations. Now, I could also go 7 in the negative direction. So the number that I put in here for x can also be going to the negative 7. I can go to the left this far. Remember, the negative sign just tells me I'm going to the left. So that means x can be negative 7. So I'm always going to get two answers. X is 7, which I get by going to the right, and x is negative 7, that I get by going to the left. So I'm always going to get two answers when I'm working with absolute value equation. So basically what you do, and this goes back to what I said right here, you take the expression in the absolute value and you set it equal to the positive of this. So I set it equal to positive 7. And then you also set it equal to the negative of the other side of the equation. So notice I set what's inside x equal to the negative of what's over here. And that's true for what's ever over here. In other words, if I have absolute value equals x is equal to some expression over here, if let's say this is a 4, then it's just equal to 4. If it's equal to x, then it's equal to x. If it's equal to x plus 3, then it's equal to x plus 3. It's equal to this whole thing, the positive of this whole thing, or the negative of this whole thing. Okay? In other words, let me use this example real quickly. If I have the absolute value is equal to x plus 3, my two equations are what's inside, x equal the positive of this whole thing, x plus 3, which again ends up being just x plus 3. And the other equation is x equals the negative of this whole thing, x plus 3. And it's good to use parentheses because you'll notice this negative sign makes the x negative when I distribute. It also makes the 3 negative, so this would be equal to this. So then I would solve each of these expressions. All right. So that hopefully you got that. All right. If you're not, again, write some questions down and we'll take care of that in class if we didn't. One more thing, or one example. So if I had 2x plus 7 is equal to 7, what's x? Well, the absolute value, I take what's inside, 2x plus 7. I set it equal to the positive of this side, okay, which just ends up 2x plus 7 is equal to 7. And then I also set what's inside equal to 2x plus 7 equal to the opposite of whatever's over here, 7. So 2x plus 7 is equal to negative 7. And then I go ahead and simplify that. So 2x here is equal to 0, x is equal to 0, dividing by 0. And 2x is equal to negative 14, so x here is equal to negative 7. So I have two solutions, 0 and negative 7 are my two solutions to this. All right, so go ahead, and what I'd like you to do right now is take a look at number 2, number 5, and number 6. So here are the answers for 2, 5, and 6. Go ahead and check those and make sure you check your work. Don't get caught on this negative one. I did. I started to work this one and then forgot. Oh, that's negative. Remember, distance can't be negative, so there's no solution to that one.